In this problem, we are given the circuit diagram in part A, and in part B, we are given the Norton equivalent of it. This is the formula that we would need for a Norton equivalent, and we need to find the I Norton and R of Norton for this. We're going to look at part A and rewrite it so that it basically looks like part B. Once we do that, we're going to have our I of n and our R of n. When we look at the part A, it's actually quite simple. All we have to do is rewrite it. When we look at our current, we see that it's going up this way and through the 7.6 kilo ohm resistor. Well, we don't need all of this space right here in between the 7.6 kilo ohm resistor and the 1 milliamp current. We don't need that. So what we do is when we redraw it, we are going to have our current is going up here, and then our 7.6 kilo ohm resistor will be right here. From here, we know that we are going to have a terminal A, so we can draw that. The next thing that we're going to have here is our A terminal. After our A terminal, we're going to go straight into a 6 kilo ohm resistor that's between our A and B terminals. So we're just going to draw this between, and then we're going to have our B terminal right here. We know that right underneath our 6 kilo ohm resistor, in parallel with it is this 4 kilo ohm resistor, because once current goes through here, it splits between the 6 and the 4. So what we can do is right underneath here, just like in the drawing, draw a 4 kilo ohm resistor and connect it with our B out here, and then connect this with our 1 milliamp, because we can see that current will flow from the B all the way back into here. Now when we look at this, there's a few things we can note. All we have to do is rotate our A and B 90 degrees this way, and it'll look exactly as it does here. We're going to do that in a second. However, there's something important that we should do first. We can see that our 6 kilo ohm resistor and our 4 kilo ohm resistor are in parallel with each other. So we can use the parallel formula for resistance by doing 1 over the first resistor plus 1 over the second resistor, all raised to the power of -1. If we do this, we are going to get that it equals 2.4. So I'm going to redraw this again. We know that our A terminal is going to be all the way over here, because we can say that our 6 kilo ohm resistor is going to look like this and come down here. And actually it's not even a 6 kilo ohm resistor anymore. We know it to be a 2.4 kilo ohm resistor. So we're going to put this right here. We know that current flows through a resistor, and after it comes out of the resistor, it's going to be the same current. So once it flows through this 7.6 kilo ohm resistor, it's still going to be 1 milliamp. So we can kind of disregard this resistor. If we don't even look at the 7.6 kilo ohm resistor, we can see that it's equivalent to our part B right here. We have our I1, which is 1 milliamp, and our R1, which is 2.5 kilo ohms. So that is the answer and work for this problem. It's easier to see usually when we rewrite circuit diagrams as something a little bit more familiar and a little bit less weird looking. If you want more introduction to circuit analysis problems, there'll be a playlist linked below with all the course material as well as notes for all of the course material in the description.